Today's lesson is from 5.1. It's understanding linear functions, and your EQ is what is a linear function. So after this lesson, we're going to be covering these 4 I can statements, and hopefully these are the things that you'll be able to do or being close to being able to do. I can determine if a given point is a solution to a linear function. I can graph a linear equation given a table of values. I can rearrange an equation into slope-intercept form. I can recognize equivalent linear functions represented in different ways. So here's some vocabulary for today. You need to know what a linear equation is. It's an equation whose graph is a straight line. So a question came up in the chat, do we do notes? You will do notes, but again, you don't have to do them right this second. You can go back and do them, all right? I'd rather you pay attention and then go back and do notes, but you know, if you want to try to do both at the same time, that's totally fine too. Another definition is solution of a linear equation in 2 variables. Any ordered pair that makes a linear equation true. The graph of a linear equation represents all the solutions of the equation. And then linear function, a function whose graph is a non-vertical straight line that can be represented by a linear equation. So linear equations and linear functions are very similar. All linear functions are linear equations, but not all linear equations are linear functions. So if you have the graph of a straight line and you think about its slope, you have positive slope, you have negative slope, you can have 0 slope, and there's also undefined slope where it's a vertical line. Now, if it's a vertical line, this is not a function. If you guys remember back to last week's lessons, we talked about the vertical line test and how a vertical line moved across a graph. If it ever touches a point more than once vertically, you have a repeated x value going to different y values, then it fails at being a function. That would be a linear equation if it's a vertical line, but you cannot have a vertical line that is a linear function. And when we talk about equations, there's 3 forms that you should be familiar with. The first is standard form. Standard form, A, B, C. These are integers. AX plus BY equals C. X and Y, in all of these forms, these are your variables in your equation. They're going to stay as X and Y. They're the changing values. But the A, the B, and the C in standard form, those are, in fact, integers. Those are numbers that are like 0, 1, 2, -7, -6. No fractional part, positive or negative or 0. Slope-intercept is where M represents the slope, which is just a number, and B represents your y-intercept, which is also just a number. So M and B are numbers. They don't have to be integers here. They could be any real number. And then y equals mx plus b. That's slope-intercept form. We use this a lot in 8th grade. And then finally, point-slope form, where m, again, shows up as a number. It's the slope. And you have a point, which is an x and a y value, x and a y coordinate. But notice I have x1, y1, because you don't want to confuse these 2 numbers that are being substituted in with the variables x and y. So y minus y1 equals m times the quantity of x minus x1. All 3 of these equations have x and y. And you can take any equation and typically rewrite it in a different form. And depending on what you're trying to do, one form might be preferred over the other. Okay, so this slide here is a video through Khan Academy. And it's going to show you how to tell if a point is a solution. So what you're going to do is watch this video in just a minute. Then on the next slide, you're going to answer a question that you can answer after you watch the video. The video will explain to you what to do. Then on slide 6, you have an example of graphing from a table. So here's your table of x, y values. And then we have a graph where they're plotted. And then on slide 7, it's an interactive pair deck slide where you're given a table of x, y values. You have a row of your x's and a row of your y's. Okay, so it's a little bit differently set up. And it's representing the equation y equals 2x. So using this table, you're going to plot the ordered pairs on this graph. On slide 8, you have another video to watch about slope-intercept form. And then on slide 9, you have a question about slope-intercept form. It says, what is the slope of the line? Here's your equation, 8x minus 6y equals 1. This is standard form. So, hint, rewrite the equation in slope-intercept form. You're going to have to rewrite it so you can easily identify the slope. What is the m? And when you're in student mode in just a second here, you'll be able to go all the way back to any slide you want to. And you can see slope-intercept form, slope is m. So if you get in this form where you solve for y, you can recognize the slope. And then slide 10. So linear functions can be represented in many forms. And this is an example where we have one linear function represented 5 different ways, but it's all the same function. It's just, it looks different. So right at the top, we have the ordered pairs. -1, 5 is one of the ordered pairs. And that shows up in the table. -1, 5 is in that table. It shows up in the graph. It's a plotted point. If you go to -1, +5 on the graph, it's plotted there. If you look at the equations at the bottom that represent this set of ordered pairs that represent the line in the graph, it's actually the equation y equals -2x plus 3, or in standard form, 2x plus y equals 3. If you want to say it as a sentence, it's the sum of 2 times x and y is 3. All right, so there's different ways to represent the same exact thing. And then your last slide that you're going to try is to figure out, does the table, okay, you have an xy table, and the graph represent the same function? So using the fact that you can look at linear functions in different ways, are these the same? How do you know? All right, so right now at this point, I'm going to turn it on to student paste, and I'm going to share a different tab with you. You're going to take until 2:25, which is should be enough time. You know, is I'm going to stop the student pace, not paste, to stop student paste for a little bit here. And we're going to go through some of your responses and see how you guys did and review the answers. All right. I'm sorry, Kayla. I thought I gave you feedback on one of them. So I'll go back and check for you in just a few minutes, okay? So we're going to start over back at, I think it's 5. Yes. So after the video on slide 4, this was the first one you had to answer. I couldn't get feedback on this one because once somebody put the correct answer and I marked it as right, then I couldn't get to anyone else's little dot. So you may have got it right and I just wasn't able to tell you. And it wouldn't let me tell you if you were wrong. So I got to redo how I do the multiple choice ones in Pear Deck. But let's go ahead and take a look at this. It says, which of the following ordered pairs represents a solution to the equation below? Y equals -2x minus 2. So choose one answer. You're looking for an x value and a y value that make that equation true. So if we check the first ordered pair, x is -2 and y is +2. So if I replace the x with -2 and I replace the y with +2, I want to see if 2 equals -2 times -2 minus 2. And so I have to simplify the right-hand side. -2 times -2 is +4. +4 minus 2 is 2. So 2 equals 2. That's a true statement, which means that A is the correct answer here. A is correct. For number 7, we take a look at some of your responses. Here's a good one. We have the 4 ordered pairs, and then they drew a line through the points. Now, the line is correct. If you didn't put the line, I didn't mark you wrong, though. So from this example, because this is a table of ordered pairs and they're plotted without a line, and then this is a table of ordered pairs. So if you didn't connect the line, it's okay. But technically, you want to, because these points they're not part of a real life situation like on the last slide with the race car. Here they're representing the equation y equals 2x. So actually when you graph a line that you're given the equation, you do want to plot the points and connect them with a line. The only thing I would change about this graph is by adding arrows to the beginning and the ending of the line. Okay, so here they have their line. This is good. Again, I would add the arrows. There's the point. That's also good because that's what was on the last slide, so you're following directions well. But I would also include a line. For 9, this is another multiple choice one. What is the slope of the line? 8x minus 6y equals 1. This equation is in standard form. And if I want to get the slope-intercept form of the standard form, I have to rewrite it. And the slope-intercept form is really useful when I want to know what the slope is because it makes it stand out. It's the x's coefficient. All right, and so for this, I want to work it out, and I want to show you what I'm going to do. This is kind of a little bit different. So I'm going to open a Jamboard, and you're going to be able to see it. And so I'm sharing it on our Google Meet. And there is a link to it in our Google Meet chat. All right. But on this Jamboard, because I have a stylus, I'm going to write out this equation that I am trying to rewrite in slope-intercept form. So I'm going to show you how to do that. We have 8x minus 6y equals 1. And I think you can either, if you join the Jamboard, then you would be like right there seeing it, and then I can change settings where you would have a chance to write on it. I think with this one, it's a view only. But what I'm trying to do is get it into slope-intercept form, which is y equals mx plus b. Okay, so I have basically a literal equation, 2 or more variables, and I'm solving it for one of those variables. I want to solve it for y. So I need to get the y by itself. And so in order to do that, I have to get this x term off of where it's at. It needs to be on the other side of my equation. So I'm going to do the inverse operation of subtracting 8x and then subtracting 8x over here. So those will go away. And then what I'm left with is I don't want to forget about this minus in front of the 6y. So it's negative 6y equals negative 8x plus 1. Okay, so notice I'm putting all the pieces in the right order. We have the y term and then equals, and then I have the x term, I have my x term, and my b, which is the constant. All right, but I'm not quite done yet because I have to get y isolated. So by boxing and walling, I know that I have to undo the multiplication. And so I use the inverse operation, which is division. And if I divide the left side of the equation by negative 6, well, I should divide both terms on the right side by negative 6 as well. Then they get eliminated, and I'm left with y equals, well, negative 8x divided by negative 6. I know that when I divide two negatives, I'm going to get a positive back. So 8/6x plus negative 1/6. And so my slope is whatever is right here. Sorry, I thought that would be like highlighter. It wasn't. My slope is that m. So this is my m because my y is isolated. My constant's in the right spot. So which fraction is equivalent to 8/6? So I got to think. 8/6. If I simplify it, I could divide 2 out of the numerator and the denominator. Well, this is kind of a cool pen. It looks like a marker. 8 divided by 2 is 4, and then 6 divided by 2 is 3. So my slope that I want is actually 4/3. 4/3. So the correct answer is C, 4/3. Back on our slide. C. And then we talked about linear functions being represented in different ways. And so does the table and the graph represent the same function? Yes, I think it does, because x and y have different numbers but don't change. The table and the graph represent the same function. I know this because the slope starts at 5 and goes up from there. Yes, because the data on the table matches the data on the graph. I like this answer. This is very, I mean, they're all yes, which is true. But as far as like reasoning why it's true, this is absolutely correct. The data in the table matches the data on the graph. It does represent the same function because the coordinates are both. Maybe they mean the same. Yes, the table and the graph have the same function. I know because I plotted the numbers in the chart and gave me the same graph. That's great. Okay, yes, it does because all the dots are plotted in the right spot. Those are all really good answers. Okay, so the answer is yes to this one. All right, so what I'm going to do now is turn this back to student paced. Okay, and